You worked with this, you just didn't realize that that's what you were doing. Angles of elevation, angles of depression is basically line of sight up, line of sight down. That's it. So what I'm talking about here is...
Is this going to make me depressed?
No. Now, what I mean by line of sight is that if you are standing, just standing on the ground, and I'm looking straight ahead, my line of sight is always parallel to the ground. It's parallel to the horizon, the horizontal axis, if you will. Okay. So my line of sight is always parallel to what I'm standing on. Okay. Now we did this in the auditorium, where you had line of sight, you guys were looking up. You were actually solving for what was called an angle of elevation. You were looking at objects, oops. You were looking at objects, oops.
Wow, look at all those objects.
You were looking at something up on the wall, up there. So you had this line of sight, remember, that was parallel to the ground. Your eye value was so many inches off the floor, and you looked upward at some angle. You guys were actually using an angle of elevation. Angle of elevation is the angle looking up to an object. Okay? It is the angle looking up. So, in essence, depending upon how the diagrams and things are drawn and shown to you, you can either have that, isn't that cough great? It's going to be fun. I hope it goes away faster for you. Yeah. It's going to basically, again, it's just drawing diagrams and labeling triangles. Okay? It is very, very, very straightforward. For example, a man is flying a kite with a 100-foot string. The angle of elevation of the string is 52 degrees. How high off the ground is the kite? So there's a couple of things you can take into account for something like this.
48.
You are flying a kite.
48.
You would think.
Oh, beautiful.
There's your kite flying up in the air, right?
Right.
Yeah. It's just strapped to the ground? I thought a man was flying.
Hey, yeah, exactly. Squint a little, you'll be fine.
How high is he holding it?
And that's one of the things here. It doesn't say, so we just assume he's sitting on the ground.
Alright.
Well, where is he?
He's laying it. That's him. That little dot. That's him.
He gonna get a sticker.
I'd crunch him.
Oh
my gosh.
There we go.
He's just hanging out.
Why is this real?
That's a little high off the ground.
Not drawn to scale.
Not to scale.
Oh, shucks.
Yeah, welcome back. Thank you. So what happens is, it tells you something. You know how long the string is in this case. What would be labeled as the string being 100 foot? The hypotenuse, good.
Yeah.
The hypotenuse would be 100 foot. The angle of elevation is this one here, 52 degrees. You're going to automatically, for these things, you're going to assume that we're going to create right angles off vertical. Okay. What I mean by that is, you're directly underneath the object. If you dropped a line down to the ground, it would form a right angle. That's how we measure vertical height. What are you trying to find? An opposite or an adjacent? An opposite. So in this case here, I'm trying to find an opposite. I know a hypotenuse. What trig function am I going to use? Sine. The sine of 52 is my opposite over a hypotenuse. How do I get x by itself? I don't flip them. What do? I multiply. And now, again, the idea is that you guys were able to show me you know how to type, telling me on Friday that you know how to set up the problems, which obviously you do.
Oh my gosh!
So now all you have to do is press the button, and it gives you an answer. That's the whole point of doing that. How high off the ground is it? Yes, sir.
So people are equal.
I still see that.
What workforce would
Just about anything. Surveying, I mean, I got a whole bunch of different problems of this.
I'm not trying to say like, oh,
No,
no.
like, no, I'm just saying, I'm like curious.
Remember how we talked about this before? You had those survey people out there?
Yeah.
You're wearing a hard hat. And there's this laser beam being shot out over there trying to measure this, stuff like that. That's how they do it. Where in my neighborhood, they're doing a lot of building. The houses are going up like crazy out by us. And how they actually, do you guys, I'm sure you guys have all seen bulldozers and the big scoop tractors digging big giant holes for foundations before, right?
Yeah, scooper truck.
Yeah, scooper, I don't remember what it's called, whatever. They actually, I was talking with my builder, and when we were talking about, what we did for a living and all that kind of stuff, and I was explaining that I teach high school math, he goes, that is the only time I've ever used trigonometry is when I place foundations on the plots of land of your, whatever your property lines are. He goes, I go out there and he will measure out, and he uses surveying equipment like this, and he uses trigonometry to measure out angles of repose and stuff like that off of your what do you call it? What are the lines? What are those lines called? Your
Foundation.
not foundation, property lines.
Oh.
So if you have a plot of land, let's see, a lot of something like this is the plot of land, and you have to have a certain amount of feet for your sidewalk. You have to have certain easements off of certain values. He sits out there and he does a lot of calculations with trig, and he figures out what's the best placement to dig the hole for the foundation to go in for them to pour the concrete. And I thought it was really cool.
Does he use a TI-30 multi-view calculator?
Probably. I mean, it's all you need. Really, it's all you need.
Wait, so should we keep these notes for like the rest of our life?
Yes.
To be honest with you, when you get to altitude, as long as you remember your special right triangles, 30, 60, 90, 45, 45, 90, and what in the world SOHCAHTOA means, you're going to be fine.
Really?
So yes, they use, in construction, trigonometry is all the time. All the time. All right? That's how they go out there and they'll stake all this stuff out. Everything's measured out to within certain degree measures. That's pretty cool. You actually will see this, what I was saying about this whole surveying stuff. If you have ever noticed on, basically nowadays most tractors, they've got a newer tractor, it's a bit of an old one, but most bulldozer things, you'll notice they've got the, what looks like spike pieces on the ends of the bulldozer part. You know how like on snow plows and have the two little prop heads? But those things actually are GPS locators. So they're actually bouncing off of this machine, will be placed on a plot of land, and it'll spin the laser, and as the bulldozer gets close to it, it starts beeping and it says, hey, you have to set in at a certain angle here, and it tells them how far to go through. It's kind of like how farmers plow their land and do all their lands. It's all computerized. They pop up the computer in those big giant combines, and it knows the soil, the levels and everything like that, how far something's supposed to be plowed and put through. But it's all basically a laser beam and trig. So you use it a lot. I mean, you're not hand cranking out all the calculations nowadays because of computers, but back in the day. Yes, sir.
Everything has an angle like building and stuff has sometimes a tree done to it.
Yes, sir. Yeah, if you think about it, it's how things are measured to know if things are square. Okay. If you know that something's square, you measure out 3 feet, 4 feet. Come across the hypotenuse, should be fine. If it's not, you're out of skew. Your walls aren't going to be straight. Back to this then. So again, it is quite literally drawing pictures and figuring out what values things are going to go to. I'll show you another one. John wants to measure the height of a tree, and I apologize, this doesn't blow up as well as I'd hoped. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? Now, when you measure height, do you measure diagonal height or do you measure vertical height? So when your doctor says, hey, let's see how tall you are, they tell you to slant over? Again, what we're doing here is we're drawing
Triangle.
a tree.
Tree. Yeah, then a triangle.
It says the guy walked how far from the tree? 100 feet. And he looked up from the ground, it made what type of an angle? 33 degrees.
Yes.
What trig function are you going to find to get the height? Tangent, very good. You're going to use tangent to get your vertical height. You know what your adjacent is, it's the 100, it's the horizontal distance. You're trying to figure out what the vertical height is. That is the opposite. So we're going to use tangent. The tangent of 33 is opposite over adjacent. And again, what do you do to solve for x? Well, you have to
Times
multiply that by 100.
100 times the tan of 33 equals x.
Equals the answer.
And there's your answer. Whatever that decimal equivalent. Remember, when we start to get to stuff like this, make sure you're always rounding to 2 decimal places, please. Yes, sir.
Can you like minimize it? This is very tricky, so I can do right.
Oh, sorry.
That's all right.
And I forgot to run off some of these. Yes, ma'am. No, it could be, each problems can be different. It's certain information can be given differently too, and I got a couple of different examples. All right. Excuse me. Show you a different one. You ready?
Yes.
Let's do a depression. An airplane is flying at a height of 2 miles off the ground. The distance along the ground from the airplane to the airport is 5 miles. What is the angle of depression from the airplane to the airport? All right. So, what do you need to have? Well, yeah, but it's talking about a what? An airplane. So we should probably draw an airplane.
It's like a dolphin or a fish or something.
They're now flying in Murphy,
Oh,
Maryland.
That looks fine. Yeah.
The temperature in DeKalb, Illinois is 42 degrees.
There's your airplane. Okay?
Where's the airport?
The airport.
Andrew.
Like a what?
And there's the sonar radar, the radar tower. Now, it gives you information. It tells you the airplane is how high up in the air?
5 miles.
2 miles.
I don't know where I ever got 5 from.
Everyone got 5
And it says the distance along the ground from the airplane to the airport is 5. Now, is that the hypotenuse or is that the horizontal distance? It's the horizontal distance because it says distance along the ground. Now, the 2 and the 5, are they in the same measurable unit? What I mean by that, are they both in feet, both in miles, and all that? This is it's very important to always double check that because there will be times that it does switch between units on you. They want to know, what is the angle of depression? Kind of curved at the end there, sorry.
I heard somebody make this sound like.
There, that's better. Ish. Angle of depression. Angle of depression is line of sight down. So if my line of sight from the airplane, it would be this would be my angle of depression. Now, line of sight is always parallel to what? the ground. Which means this is two parallel lines cut by a transversal. Which means line of sight down is the same thing as line of sight up. Up.
Oh.
So you're trying to find that angle.
The theta.
The theta.
Was. Then this is the op. The J. And it's tangent.
So in this case here, you have to use what?
Tangent.
So we use tangent of theta will equal our opposite, which is 2, and over adjacent, which is 5.
Pretty sleazy. Pretty sleazy.
How do you undo a tangent? What is it?
Isn't it?
How about none of those?
Division. You do
It's called inverse.
negative
Inverse.
inverse of 2 over 5.
Okay. And then you put the 2 over 5 in parentheses. And then you put it in the calculator.
So guys, now here, this is how we set this up. It is exactly the same stuff that we did all last week. Put your foot down. The same stuff we did all last week, except now you're in charge of drawing your own pictures.
Yes.
So what do you get for your angle then? What is it?
Oh, like the calculator?
Yeah,
Oh, 26.5.
two decimals?
Oh, 26.56.
26.56.
I did 2 over 4 instead of 2 over 5. Sorry.
It's okay. So what was it? 20.8. Now, I said, here's the deal. Let's say you did, and this is a good example, guys. He accidentally put 2 over 4 instead of 2 over 5, but did you write down 2 over 5?
Yeah.
Okay, that's good, because that means that, this is why I was having you guys write this all out last week, by telling me that you know how to set up the problem, that means you know what you're doing. By accidentally using a 4 instead of a 5 just tells me you're a doofus.
Yeah, you're
But
a
it's
dingus.
not wrong. You know what I mean?
I wasn't talking
Remember
to
that.
No one was talking to you. No one asked you to speak.
Anyway.
He's being
But-
I
rude.
don't like that.
Anyway, so, but you see what I mean by that?
Yeah.
You're not doing it wrong.
You're
And that's
both
fine.
thumbs up.
I'm gonna throw my Chromebook at your head.
Remember that.
Guys,
Okay, let's stop.
come on. And I'm glad you actually made that mistake. Now guys, listen. This is hugely important. The reason why I kept telling you guys every time to write this out is for this exact example. Isaiah wrote everything out. He was absolutely perfect in doing all of his trig right. He just hit the wrong button. That's not the end of the world. It's not. Because we're not trying to go to the moon. We're trying to set up simple geometry high school problems. This is more important than getting the decimal correct. Yes, sir?
You know I want to be an astronaut.
I did not know that.
I've always wanted to go to space.
Good luck.
That's
And
awesome.
geometry. You gotta be good.
Okay? That's awesome.
Yeah, I know.
You gotta be really good at this. Yes, there's a lot of science in that.
Yeah.
Okay. All right, let's try another one.
You mean there's a lot of math and science?
Yeah.
There's not a whole lot of science in math.
You mean there's a lot of doing this?
Wait, what?
There's a lot of
Guys,
math and science.
can we stop, please? Come on. A bird is on a lamppost. The angle of depression from the bird to the foot of an observer standing away from the lamppost is 35 degrees. A lot of times when they get to these things, they're always going to be talking about either horizontal or vertical distances. It is very difficult to measure a diagonal distance. Quite honestly, usually the only time you have a measurable diagonal distance is with kite string or an anchor, because you know how long the anchor chain is. Does that make sense?
Yeah.
Because that, as it goes in here, because you know boats will drift, they'll move.
Yeah, like.
Well, that's swaying, but
Well,
it will
yeah,
get your.
yeah.
So it's the same basic idea. So if it says that the distance from the bird to the observer is 25 meters, think of this as being the horizontal measurable distance. I can see that there's the lamppost, and I can walk off 25 meters or 25 feet, whatever it might be. Okay? That's what you're looking at being able to work through with something like this. So, bird on a lamppost. The angle of depression from the bird to the foot of the observer standing away is 35 degrees. That person's 25 meters away. How tall is said lamppost? Well, what do you need to draw?
The lamppost with the
Lamppost.
bird on it. Put the bird on it.
It's going to be awful.
Mr. Murphy, can I go to the bathroom?
Yes.
Okay.
That's a pretty good bird.
Kevin, you know what? Go somewhere.
It's awful. I get it.
It's on 10:50. 10:50 now. February06.
Remember, angle of depression is the exact same thing as you flip alongside the inside of the transversal there as the angle of elevation. They are congruent to one another because of parallel lines and transversals. So, excuse me, we're trying to figure out how tall that is. We know that this is 35, and this was, what, 25 meters?
Potatoes, 35?
Yeah.
Okay.
All right. What happens a lot of times with angles of elevation and depression is that if you're not careful in how you draw the diagram, you're just going to flip-flop your opposites and your adjacents that way. So you just got to be very careful about remembering what they mean as you draw them through. Okay. Whenever you're doing these types of problems, you're always going to solve more often than not, or work with an angle of elevation, because it's an easier one to find. Okay. Excuse me. So what do you get? Or what trig function are you going to use? Excuse me. Tangent. Now I have the angle, so I don't have to worry about pressing inverse here. So I have tangent 35 is x over 25, right? To write that out, then, it's just going to be the 25 times the tangent of 35. And what do you get for your vertical height? 1751? It's actually a really tall lamppost if you think about it. A meter is just a little bit over 3 feet. So that's just under 60 feet tall. Yes, sir? Meters equals x in this whole. I like your shirt, though.
Thank you.
Thanks.
Bob Ross, man. Happy little trees.
Good one. Love it.
Okay.
Nice shirt. You look like a leopard. That's overgrew. You got it?
You're a little much today.
Yeah, you're a little much today. Yeah, Kevin. You need to
You're a
calm
little
all that
mesh.
down. Mr. Murphy.
Yes, ma'am.
When he gets back, can I go to the bathroom?
They start tracking Riley too.
How much I'm back? I can make it in 30 seconds with my hands washed and one pee.
Yeah, he takes scorpions every time.
A great white shark swims 22 feet below the sea level. If the shark is 67.7 feet from the sailboat, what is the angle of depression of the boat to the shark? So, in this case, we need a bigger boat, yes. Shark in the water, cage in the water. Have you not seen Jaws?
Yes.
My mom was in Jaws too.
Anyway. Farewell and adieu, all my spare
How do they do that?
friends.
Do they get a real shark?
Farewell and adieu, my ladies of Spain.
It's not a no, the
So
shark
we
is
need
not
a
person.
shark.
She thinks that the shark that they used the shark was a real person.
Wait, no.
Like a person was in a shark costume.
So
You forgot the fin. The side.
So, one of the greatest joys of parenthood when you have children is helping them learn different things and teaching them stuff, animals and numbers and math and whatever. And when our kids were growing up, as most kids do, they love animals and animal books and sound books and all that. What does the monkey say? Things like that. And then you had elephant, they go. What they often asked, we would say, hey, when they see the shark, do you know what the shark sounds like? So what we've taught our children.
Dun, dun, dun.
Did you even wash your hands?
We taught our children that the sound the shark makes is. Dun, 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 dun. So for the longest time, kids would ask, what does the shark sound like? They go, dun, 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 dun. So it's great. I know it's so wrong, but I highly recommend it if and when you do have children, if you do have kids. It is a great thing that you'll feel a sense of pride when you teach them something kind of silly, and that's one of our favorites. So.
The Jaws soundtrack is.
Then here's your boat. So, excuse me. So we know that the shark is 67 feet from the boat, and we measure distances horizontally. We know that the shark is how far off from the bottom, from the sea level, excuse me.
22 feet.
So this is your 22 feet down. It's over 67 and change. What you're trying to figure out is the angle of depression to the shark. Now, the angle of depression to the shark is the same as the angle of elevation from the shark looking back at us. Excuse me. So I need to figure out that theta, which means what trig function am I going to use? Tangent.
Tangents.
No, I don't want you to think that you're always, because we used sine earlier.
Yeah.
They all kind of show up. Usually speaking, tangents and sines are the ones that are used more often with elevation and depression. I guess you can use the other ones, but more if you think about it, you can always measure a horizontal distance with a tape measure. So it's that's why you don't see a lot of adjacents being used. So if you put that in the calculator, you have to use what? The inverse again.
Would it just be 18? Just get 18.00.
It's 18 point what? 00 something? 002. So yeah, it would be 18. That means your angle of depression, 18 degrees. Okay.
I guess it works.
Well, I want you to. That way, I've got some for you guys to draw out real quick, so you can throw these as parts of notes. Just a lot of stocking a lot.
I like your powers.
I don't know what one he is.
Why do these sound
Like who?
I do that all the time.
Just trying to work it out here a little bit.
on your grass.
All right, so let's do this. Take a look at number 2 real quick as this is coming up to you. Thank you. There might be a few extras lying around. Take a look at the second one. The second one says, an airplane is taking off 200 yards in front of a 60-foot tall building. What angle of elevation must the plane take off in order to avoid crashing into the building? So, it's in front of the building.
Where are the windows?
Oh my god, I forgot.
Oh my god, Tori.
So it tells you a couple bits of information. It tells you how tall the building is. How tall is the building? The building is 60 feet tall. And it also says that the plane is how far away? 200 yards. Notice right away that we have two different units of measure. We have feet and yards. What should we convert it to?
Yards.
Feet. I would always go with feet. In this case, there's nothing wrong with yards because it's divisible by 3. But I would go to always work down a unit because you will be less likely to have to worry about decimals. This case, it would work either way. You're going to get the same answer. It would always work either way if you do it correctly. But I always think it's always easier to multiply than it is to divide. So how many feet are in a yard? 3. So what's 3 times 200? 600.
I'm sorry. I
So now you need to find the angle of elevation, which is that. What are you going to use?
Tan. Oh, wait.
Excuse me. And once again, it's just a matter of pushing some buttons on the calculator. And it tells you at what angle it should climb at so it does not run into said building. Okay? What was it?
5.7.
Okay. I didn't hear you. What?
No, I said, I was, no.
Take a second, draw up the next one about the ladder, and we'll check and see how you did. All right? Take a second and try the next one with the ladder. Actually, do the next 2. We got a minute or so we can check them both. So that's what, number 3 and 4. Excuse me.
I was one of those people going to Mars, except the Mars mission. It was like in 2000. Because I never come back. I don't care.
You don't care?
I'd rather die.
You don't want to
than
come
die
back?
alone again, so it'll be-
I'd rather die on Earth where I was born than go to Rock Island. Die.
Or you can go to Rock Island.
Like I said,
You guys are all big right now.
I
just love
Now, real quick, when you draw this, 14 feet is the ladder. 13 feet is the wall. So if the wall is 13 feet, don't ladders lean against walls?
No. Yeah.
I mean, sometimes.
So which part is the 14?
I was on the wild side.
This is the hypotenuse one. How far, what is the angle of elevation that you need to use? Now remember, a ladder leans against something. You know how long a ladder is. It's a matter of figuring out the angle then. What's that?
What if it's standing on top?
Now, would you like to stand on a ladder that's just vertical?
No, but there's ones that go out.
Okay, now when they're talking about ladders, I know what you're talking like an A-frame ladder. Now,
Yeah.
what they're talking about is just a regular one that is just lean up
You
against
gotta
ladder.
lean up. That's scary. Trying
Okay.
to stand up something.
What trig function are you going to use to find theta? Sine. And then again, to get theta by itself, you just inverse the trig function. So you're just pressing buttons again in the calculator. Theta is inverse sine of 13 over 14. What do you get for that angle?
Yep.
68.21?
No big deal.
All right. Now, what would you do to figure out how far you are off the wall? If you have two sides of a right triangle trying to find the third, what's always the easiest way to use it? Pythagorean theorem. So if I wanted to figure out how far off the wall it would be, I would use Pythagorean theorem. X squared plus 13 squared is 14 squared. Well, 196, 169 gives you square root of 27.
Okay, what's up?
So what happens here is that eventually you're going to find everything.
No, I don't.
Finish the rest of this worksheet for tomorrow. All right, you just bunch of drawing pictures and solving some trick. Okay.
So